Second part, the second one, right? You may not know this, or they might not have taught you. You're right, kinetic energy is only part of the answer. So there's another term, right, for called internal energy that includes kinetic energy of the particles and the potential energy of the particles. If you have not learned it, then it's okay. Using ideas about particles, explain how heat is transferred through the metal pipes by conduction. So they want you to explain the process conduction. Yes, so they ask you to explain, so your answer must look like an explanation and not a state answer, not a state question answer. Explain. Use ideas about particles. Explain how heat is transferred through the metal pipes by conduction. So you have to tell the reader how energy is transferred with these metal pipes here. How the energy will go in. So you have air going in and air going out. Then you burn coal inside. Once you burn coal, then the coal will produce energy, right? Then they say hot gases will rise, and the thermal energy from hot gases heat up the cold water inside the metal pipes, forming steam. So they want to know how this burning of coal and the hot air inside the burner will be able to heat up water. The heat travels from particle to particle. Okay, so yeah, but how do you explain how the heat from the burner go to the metal pipes, and through the metal pipes the water inside the metal pipes will get the energy? So as the hot air, okay, heats up the pipe, what happened? This heat, that's what is converted to
It's converted
what?
to kinetic energy.
Okay, to kinetic
Water
energy.
particle.
Yes. Then particles in where?
In the pipe.
In the metal pipe. Then what happened? The particles, what happened to the particles?
Because gain energy.
Okay. They already get energy. And they get energy and
water vapor.
You are talking about the metal pipe only, you know. Okay. The particles in the metal pipes will vibrate more vigorously.
Particles in the metal pipe gain energy and vibrate more vigorously.
Yes. Then what happens next? So what happened to these metal pipe particles? So they collide with
each other.
Neighboring particles. And what happened? And
forming a
causes them
conduction.
to you want to explain the conduction process, so you cannot use the word conduction. So causes them
to transfer
more vigorously as well.
vibrate more vigorously as the particles collide,
passing Ke to them.
passing kinetic energy to them.
Hmm. So this continues until what happened? The
Continue until the heat is transferred
through the pipes.
through the pipes.
Okay. If they want you to explain how the conduction happened, then you have to write out the process of conduction. And then because they have a story down there, they say how heat is transferred through the metal pipe. So you have to say where the energy come from and how it goes to the surface of the metal pipe, then how the particles get the energy, and then after that, how does the energy get transferred in the metal pipe, and then after that, then the answer ends when the heat is totally transferred through the metal pipe. So it looks a bit long. So when you write this, right, you are simply stating how the mechanism takes place. Conduction happens in free moving particles, from free moving particles. You say heat travel from particle to particle, but you did not. This will be sufficient if you say it's a state how heat is transferred. There they have questions like they say state how something happened. Then your one with a bit of alteration will fit the answer that they fit the question. But now, right, they say explain. So when you explain, they expect step by step with more details, then your answer becomes insufficient. That's why I always like circle the state, then circle the explain, and etc. Because different keyword down there in the question will demand a different kind of answer. Okay, which is a problem for you because it's very difficult to construct a nice detailed answer for them. And which is not just only you, a lot of students cannot do that. So that one comes with practice. Suggest what might happen if cold water enters the boiler from the top instead of the bottom. Cold water enters the boiler from the top. So say water coming from here. So feel free to suggest. That means there might not be a standard answer. Whatever answer that you give and it's logical and makes sense will be correct.
Hot gases will not heat the cold water.
What happens is like this, and you check if it's what you said earlier. So what happens is if your cold water is on the top, so then the water gets heated up and it will just rise. So because you have water going in here, so when the water is heated up, it will become water heated up, it will become less dense. So the hot water will become less dense, then it will just rise. So when it rises, it will go up. So then what happens is all the warmer water will stay on top and the cooler water will come in and cool down the hot water again. Then the the heating up of the water will be less efficient.
Cold water will get heated up and rise.
Hmm?
The cold water will get heated up and rise.
Yeah, but the cold water is already at the top because the cold water coming from the top, right? So what happened is the cold water comes in from the top. The cold water comes in, the cold water comes in like that. Then there are some more water here, they will get heated up and then they'll all rise up. So they will accumulate at the top as well. So the steam that is accumulating on the top will, one, it escapes from the top. And of course, at the same point, right, cold water comes in and may cool down some of this steam. So the efficiency of the boiler will not be there because it is not doing the job properly. Yeah, here.
Cold water will come in from the top,
They
and
say that,
since there's cold water already in the bottom,
yeah,
the cold water will get heated up and rise, but then all the cold water, all the steam will be stuck at the top.
yeah. So either the steam
Then
goes
the
out.
boiler is not efficient anymore.
Yes, yes, yes. So cold water go down, it sinks. And water enter from the top, go in. The cold water sink already. Then you start boiling, and then you go up. Then at the same time, cold water still coming from the top. So as you say, it will trap on top. The steam will trap on top, and the cold water will come in at the same time. So some will cool down, some will escape if they can. So it's not efficient.